What we're going to learn today is describe the covalent bond as electrostatic attraction between a pair of electrons and positively charged nuclei. Start out, what is a covalent electron? Covalent, easily described, is co, which is together, and then valent electron, which is negative electron. So, covalent electrons, you have your covalent bonds are due to electrostatic attraction of nuclei to bonded pairs of electrons. So, each electron, let's say this is hydrogen, and each one has an electron here. So each one, when they form together, and each one would bond to create an electron here.
Have a negative charge and nuclei having a positive charge. So that resembles that when two particles approach one another, they overlap. Electrons that are between two nuclei can attract to both nuclei holding them together. So it would look like this force is called covalent bonding. When atoms form a bond, they become lower in energy and more stable. For example, H2O, which is water, has hydrogen has one valence electron combined with oxygen, which has 6, plus another that has one valence electron. Would look, when combined, they will form a covalent bonding of this. Use the Lewis structure of molecules in iron for up to 4 electron pairs on each atom. So, 4 valence shells make atoms stable. They are obtained by sharing, gaining, or losing electrons.
Okay, a mini example of this is H2. And with these, you all know that hydrogen only has 1 electron. So when they share, they are going to become isoelectronic to helium. And when a pair becomes isoelectronic to something, that just means that they have the same electron configuration. So, a way to show this for, like, I guess on the papers, you can either write it, there's 4 ways you can write it. There is X's or dots, both X's and dots, or a line. But you only use the line to show actual electron pairs. Okay. There are 2 ways to get the Lewis structure, and to show these, we're going to use this. The first way is to put the element in the center. This is going to be carbon. Okay. You missed the to find. There are 2 ways that you can find the Lewis structure. We're going to use this to find it. So first, we place the first element in the formula in the center. So that would be carbon. And then you equally space the other elements around the center and put in the valence electrons. So carbon. electrons to get the full shells. They're pretty much paired now, but just to show you these.
Go.
Second way to find the Lewis structure is to first start off by switching the valence electrons. So carbon has 4, there's 3 oxygens, so you add those, 1. And fluorine has 7, and that totals to 14. And then you divide them by 2 to get the number of electron pairs. So you will have 7 pairs. Then you place the first element in the center, which is carbon, and you evenly space the rest. So hydrogen, 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 fluorine, and then you use lines to show the electron pairs, ensuring that all of the elements have full shells. So there will be a pair. That's 4, but you still have 3 more since it's 7, so you show those as 1.
State and explain the relationship between the number of bonds, bond length, and bond strength. Okay, first is length. The single bonds are the longest, and the triple bonds are the shortest. Next is the number of bonds. Basically, it's how many electrons that are needed to obtain noble gas configuration. For example, oxygen needs to share 2 electron pairs and thereby creates a double bond. Last is bond strength. Triple bonds are generally strong since the nucleus can have greater attraction force. Since there are more negative, the electron pairs are drawn with greater attraction to the positive nucleus. Predict whether a compound of 2 elements would be covalent from the position of the elements in the periodic table or from their electronegativity values.
To give an example of this.
Okay, if the difference in electronegativity is between 0 to 1.7, then the bond will be covalent. But it doesn't work for metals alone because that's called metallic bonds. And the further a metal versus a non-metal are, the less covalent.
As a good example, there's fluorine, which loves electrons, and it has the highest electronegativity. And then you have francium, which is at the bottom of the periodic table, that doesn't really like electrons much. It has the lowest electronegativity. So more at the bottom, more elements at the bottom of the periodic table have the lowest electronegativity, and the most atoms at the highest part of the periodic table have the highest electronegativity.
Okay, today we are going to learn about predicting the relative polarity of bonds from electronegativity values. For those of you who don't know, electronegativity is the measure of the attraction of an atom for electron pairs in its covalent bond. To find the polarity of these, you have to remember that anything with a difference of 0 to 0.3 is non-polar. And anything above 0.3 is polar. An example is CO2 may bond like this.
Okay, how about this? Can you do 1 today? Okay, we can try again tomorrow. We'll try. Good shot if y'all
And their electronegativity is both 3.2. And when you subtract these, you will get 0. So it will be non-polar.